Hi, I'm Annalise Record, and it is time to talk about subtraction. And boy, do we need to talk about subtraction. I really feel it is the Achilles heel for most of our students. I work in a grade 3 to 5 school as a math specialist. I'm working in all the classrooms, and I frequently see problems, first with some subtracting, just the actual problems that are subtraction, but also we work, of course, a lot in multiplying and dividing within these grade levels. And within the division problem, a lot of what the hang up that I see is the math facts within the multi-digit subtraction. There are a lot of counting on fingers by ones, and not a lot of efficiency with those math facts, and a lot of inaccuracies. They're just getting in the way of them even understanding what they're doing. So want to make sure we talk about the running records we have for subtraction, that I'm releasing the newer version of the subtraction running record. And I wanted to touch base a little bit on how I found subtraction running record to be very different from addition. From addition, I really found that it's a very linear progression. The students ended up being in one particular strategy. I would start working with them on that strategy and then forward them down the road. And one led very logically to the very next one, all the way down the path till we got to the end with the decomposition and bridging 10. With subtraction, though, I really have found it very different. It's not as a linear progression. Of course, the beginning part of the running record, we're trying to see whether they understand the properties of taking away nothing from a number, and I found a lot of students actually give a wrong answer for that very first question. I'm not sure whether it's just the first question, whether they're just kind of getting into the realm of taking it, or I'm not quite sure what it is, but at the very beginning, sometimes they can make an error in that. But I find the first kind of stop sign that I find is subtracting within 10. So at that point, I'm giving several different expressions to kind of test this area. I don't want to just give 2 and then move on. I really want to make sure I spend time. So I want to build their flexibility of thought within that 10 before we go into the larger numbers, taking away from teen numbers. So I do find that's the first stopping ground. A lot of students I lose there. That's where they don't have the efficiency that I'm looking for, the speed, the accuracy, and that flexibility of thought. So once we get past that, if students are doing fine with that, then I find the next few strategies of breaking apart and taking away a 10 or 1s from a teen number doesn't seem to go too badly. And taking away from 10 as well, they tend to have their math facts that make 10 pretty solid, and so the subtracting from 10 doesn't go too badly. But the next hang up is those half facts. I don't think we're using that terminology a lot in our instruction, that while we also have doubles facts, we also have half facts. And just to recognize that they don't need to do any other thinking, since they really typically know their doubles facts so well. So the half facts is the next stumbling block for a lot of the students. And then we have the last one, which is actually the last second to last one on the progression. The very last one is taking numbers away from 20. But the bridge 10 of all our teen numbers, taking away numbers that get us under 10, all of those math facts are in that last strategy. So it kind of looks like, oh, everyone's at the end of the road, but is the heart of subtraction. And I do find that when they get hung up there, that is where most of our students are getting hung up. So again, it's either that first adding within 10, then the half facts gets them, and then the majority of students end up working in that bridge 10 and building that efficiency. And that is the most important strategy, because it's going to help us then do subtraction with larger numbers and decimals and fractions down the road. So, and actually most of the math facts are in that as well. So I want to talk for a second, first of all, about the progression of teaching adding and subtracting math facts. I wonder whether many of us teach the addition math facts all the way through to the end. So the students start with the +1 and +0, and they go all the way down to decomposing, and then we begin them back on the subtracting 0. And I really would suggest that we change it up a little bit, and instead that we're getting our mastery of math facts adding and subtracting within 5. And then once that is solid, then we go on to adding and subtracting within 10. And then finally adding and subtracting within 20. Because we really do want to set a foundation for the children to understand that relationship between adding and subtracting, and that the understanding that a subtraction problem could be a missing add-in problem, so that if I know the addition fact that fills in the blank, I'll be able to know the subtraction answer as well. So that if I know that I'm taking 15 minus 7, and I know that 7 plus 8 makes a 15, I'm done. I can think about, well, what can I add back to the 7 to make it be the 15? And it's just going to be my 8. And there didn't have to be any counting or any thinking or anything going on. I can relate that addition and subtraction, and that inverse relationship is a crucial relationship for students to understand, particularly at this foundational level. So I want to talk about the 4 different tools in the toolbox that I want students to have when they're confronted with a subtraction problem, because I have found, even myself, as I have done and developed my brain and thinking in these newer ways of being more efficient, I can do so many more subtraction problems in my head, even with larger numbers. But I do find that the strategy that I'm using is different based on the numbers that I'm given. It's not just a certain straight one that, oh, that particular one I'm always going to use a certain kind of strategy. I do find it's different according to the numbers, which is a different thing than with the addition. So the 4 different ways I want to talk to you a little bit about for subtraction is, first of all, our first introduction to subtraction with students is that takeaway method, that subtraction means taking away. So we have an amount, and then things are going to go away, they're going to be eaten, they're going to get broken, and then we're going to have fewer at the end than when we started with. So a lot of our students are used to subtracting and counting back. So our first level of that is they're going to count back from that minuend to get down and figure out how many are left over when they take those away. So that's certainly one way that we're going to be talking about subtraction. Another way, however, is thinking about adding up. So what if we start from the number we have and find out what can we add to that to get back up to that minuend? So use the strength of addition to help us get back up to that minuend. So I do tend to use addition a lot when I'm asked to figure out subtraction. And I actually do find in myself, my brain, I have like an open number line in my brain, and I can kind of see it in chunks trying to get myself to the nearest tens and or hundreds or wholes when I have decimals and fractions. It's a very different way of thinking than the algorithm that I grew up doing. And when I first began my career, I was not able to do any kind of mental math things very easily. I was trying to imagine the algorithm in my head, which is very hard to keep track of all those regroupings and things when you're trying to do it in your head. So one way, again, we have the subtraction, but we have that distance method of trying to find what is the distance between my subtrahend and my minuend. And I can think additionally, I can think, what can I add to get up to my minuend? We also can think of that distance and think of it in a subtraction way. So I can think backwards to get to that number I'm trying to take away and find out what was that distance between the two, but thinking in a subtraction way. And finally, if I know my addition math fact right away, I'm not having to count at all. I will know what the answer is. So that would help me out in many situations as well. So what does this look like in this early numeracy for our students as they develop? Well, within this subtraction within 10, we want to make sure that the students have that flexibility of thought even with those numbers. Because if I am asked 8 minus 2, I'm going to want to count those 2 right back. 8, 7, 6. Boom, I'm done. But what if I'm asked 8 minus 6? Do I want students counting back 6 all the way down to the 2? Well, in that situation, I want to count up. I want to think, what can I add to the 6 to get back to the 8? So 6, 7, 8. It's still my answer of my 2, but I've thought about it in an additive way, and I'm more efficiently getting to my answer. Now, this translates itself really well when we get to the math facts that are in the teen numbers, because if I'm a teen number, I can use the 10 as a bridge to help me. So if I have, let's say, again, 15 minus 8. So I'm going to think about taking away 8 from 15. Well, if I know that 15 is only 5 away from 10, I can take away 5 right away and be at 10. So rather than counting back those 5, I can do that in a chunk, and I'm right at 10. And if I know my math facts well enough that together make 10, I'm not going to have to count back anymore either. I'm taking away 8. I've already taken away 5 to get to my 10, and I know I have 3 more to go, and 10 minus 3 has to be 7, because 7 plus 3 makes 10. So I'm thinking about that as a subtraction way, but again, I'm using chunks. I'm using that bridging of a 10 to help me. Now, I also can think about it in terms of addition. So this is how my brain actually works a lot when I'm even given math facts. I just quickly think, well, 8, 2 more gets to the 10, 5 more gets to the 15, and that chunk of 2 and the 5 make a 7. So I know the answer is a 7. Of course, many students can just know the 8 and 7 make a 15, and so that math fact will be right there. And there isn't even a need to use a bridge because they know what that math fact is. So having those translates so well for mental math as well. So, and again, it depends on the numbers that I'm given of what strategy I want to use. So if I were to ask 52 minus 38, I'd be curious how you would think about that. Would you think of an algorithm and think of the regrouping that it would be? Would you start at the 52 and take away 30 and then take away an 8? Or what I do in my head, I think of an open number line. I think, well, 38 and 52. Well, I know there's 2 more to get to 40. Then I jump 10 to get to the 50, and then 2 more gets me to 52. So it must be a 2, a 10, and a 2, which is the 14. I find myself, my brain is working much more like that nowadays when I'm given problems. But of course, if I were to ask, let's say, 91 minus an 11, I don't want to start at 11 and then count up to get to 91. I may want to take away my 10 of the 11 first and be at 81, and then take away 1. and then I'm at 80. And so again, I want that flexibility of thought with the student. So we want to touch base with that within the 10, develop that flexibility with those lower numbers. And then we can extend that when we get to our teen numbers. And again, we'll extend it when we get to larger numbers and even fractions and decimals. If I were to ask 5 1/4 minus 3 3/4, well, typically we would try to think about, well, the regrouping, and particularly with mixed numbers, it gets really complicated, but the same thinking can hold true. If you start at 3 3/4, I have one more fourth to get to 4, a whole to get to 5, and a fourth to get to 5 1/4. It's 1 2/4. And I know what I'm doing. I didn't have to regroup. I didn't have to think about how many fourths were in the whole. I'm thinking of it in terms of my number sense and that distance between those two numbers. So these really important strategies, and I really think we need to give subtraction its due. I think that really it is the Achilles heel of our students, and we need to be able to fix it, and we need to give it the time and dedicate the instructional time for that, because I really do feel we have older students, even probably in middle school, who don't have those subtraction math facts done. So it's time that subtraction is given its due.